let's go ahead and start. We're going to do the integration. If you have the answer for the first one, if you don't mind, go ahead and type in that, and the second one for that matter, into the chat window so that we can go over these. So we're going to be doing integrations today. If anyone would be willing to put their answers in the chat, that would be cool. If not, that's okay too. So give you a minute to consider putting the answers in the chat window or unmuting yourself and giving me the answers. I'm cool either way. Okay, so our first answer is we've got 2/3 x raised to 3/2. Now, when I'm doing integration, especially when I see radicals, I rewrite them with equivalent exponents x raised to the 1/2 dx. The reason I do that is because it makes it easier. Just a minute. The reason that I write it as x raised to the 1/2 is to allow myself to do the plus 1, so plus 1 there. And 1/2 plus 1 is the same thing as 1/2 plus 2/2, which is the same thing as 3/2. So this becomes x raised to the 3/2 divided by 3/2, or in other words, plus c. Oh, for the love of gophers. All right, so this ends up becoming 2/3 x raised to the 3/2 plus c. So that is the answer to the first one. The answer to the second one is, again, I'm going to add 1 to both of these and then divide by those powers. So this is going to be equal to 4x raised to the 4th divided by 4 plus x raised to the 3rd divided by 3 plus c. So in other words, I have x to the 4th plus 1/3 x raised to the 3rd plus c. How was that? Any questions on those? All right. So if there's no questions, then what we're going to be doing today is we are going to be integrating between two curves. Oh, for the love of gophers. So we are integrating between two curves. We have to determine which curve is above the other. So we will determine which function is above the other function. We may or may not be given the integration from the a value to the b value. They may give us just the curves and expect us to be able to integrate. So what we have to do is we have to determine who is the function that is above, and we also have to determine whether or not these curves cross and where they cross, if they're not giving us anything else. So the way in which we determine, oh, for the love of gophers, curves, is basically what we do is we take the curve that is on the top, in this case f of x. We subtract the curve that is on below it, which is g of x, and we integrate. So I can do it individually. I can rewrite this if I'm inclined, but I probably wouldn't be inclined. I can rewrite this as from a to b of f of x dx minus from a to b of g of x dx. So I can write it by distributing the integral through, or if I can algebraically clean it up first before I integrate, I will algebraically clean it up first before I integrate. So I can do it just by the subtraction, or I can break it apart individually. So if I'm asked to integrate this, notice for this integration, for this graph, I don't have the points of integration. So I'm not given these 2 points of intersection right here. I'm not given the a or b. So because I'm not given the a or the b, then what I have to do is I have to figure out what those x values are. Well, in the graph I can see it's going to be at 2 and -2. But if I didn't know where they were because I didn't have it graphed, then I'm just going to do it so that I set, because I have y equals and y equals, this is the same thing as, since y is equal to x squared minus 3 and y is equal to 1, is I can set those equal to each other. So then I would just solve. Again, this is if I didn't have the graphs in front of me. So I would just solve. I'd add 3 to both sides and I get x squared is equal to 4. Take the square root of both sides and I get x is equal to plus and minus 2. And that tells me my limits, so -2 to 2. Now here's the thing though. This thing is symmetric. So in other words, I could just do it from 0 to 2 and multiply the answer by 2. And that would work too. So I could integrate from negative 2 to 2. And if I were to integrate it from negative 2 to 2, I would take my top function. And my top function in this case happens to be 1. So it is f of x minus g of x dx. And for this particular case, that the function that is above the other is 1, is the function that it's above. And so I can integrate it from negative 2 to 2 of 1 minus x squared minus 3 dx, which is equal to negative 2 to 2 of 1 minus x squared plus 4 plus 3, because I already did the addition, plus 3 dx, or in other words, from negative 2 to 2 of 4 minus x squared dx. Now, because of the fact that this thing is symmetric, then I can rewrite this as 2 from 0 to 2, starting with 0 and going to 2, of 4 minus x squared dx. And that's because I have symmetry about the line y equals, or about the y-axis. So if I didn't have that symmetry, I wouldn't be able to do it, but I have that symmetry, so I can just do it from 0 to 2. Now, if I have symmetry somewhere else, say along the line x equals 7, then I can do it from 7 to wherever. So I'm looking for that symmetry, and if I see that I have symmetry, then I can do half of the work, because I know when 0 is in there, it's so much easier to do the integrations. So I go ahead and I integrate this thing. So I'm going to stop and let you all integrate this. How about that? Once we've done the integration, don't forget to actually plug in the values. This is why I like to use symmetry, is because I see that I'm going to have that 0 in there. So that means I didn't have to do the fraction with the negative 2. And so we're going to have 2 multiplied by 4 times 2. 4 multiplied by 2 minus 1/3 multiplied by 2 raised to the 3rd minus 2 times, and then we have 0. So we like to have that 0 there. And so I end up with 2 times 8 minus 8/3. And then I have to multiply that 2 through, but before I multiply that 2 through, I'm going to go ahead and make this a single fraction. So 3 over 3, which gives me 2, and then I have 24 minus 8 over 3. And 24 minus 8 is what? 16 times 2, so 32 over 3. Is that what we have for an answer? 32 over 3? Okay, cool. So, any questions for me so far? Do we have any questions? All right. So if we have no questions, let's go back over here. Now, what I know without actually going to Desmos is that this graph is going to be this is going to look like that. So by the basic transformations of graphs, that's what the graph will look like. Now, this one, because this is negative, and if I were to factor that out a negative, so negative x, and then x minus 18, I know I'm going to be crossing at 0, and I'm going to be crossing at 18, and it's going to be upside down. So it's going to have a graph that looks like this. So if I bring these two together without going to Desmos, then my other graph is going to look something like this. Okay, so this is my first one, and this is my second one. So I can see that my second graph is actually above my first graph. So I know that when I do the subtraction here, when I do the integration from A to B, it's going to be the second one minus that first one. Because I know that I can see that my second one is above. But what I do need to know is what that point is. So I have to set them equal to each other and solve. So knowing all of that, I'm going to set them equal to each other. So I have negative x squared plus 18x is equal to x squared. I'm going to factor out, or I'm going to bring that x squared to the other side, so I have negative 2x squared plus 18x is equal to 0. And I'm going to factor out a negative 2x, so negative 2x leaving me x minus 9 is equal to 0. So I know that this x value is when x is 9. So a lot of algebra without using any graph. So what I know now is when I integrate this, so you all are going to integrate it. You're going to go from 0 to 9, because that's where they cross. You're trying to find this region right there. And we know that the second equation is above the first equation. So you're going to write negative x squared plus 18. That's 18x. That is my first equation. And then minus my second equation, which is x squared dx. So my second equation was above the first equation. So it'll be the second equation minus the first equation. And so what this will end up being is integrating from 0 to 9 of negative 2x squared plus 18x dx. So go ahead and integrate that and let me know what you get. And if you're done with that one, you can go on to C and D, please. Okay, looks like we have some confirmation on the numbers. So once we integrated, we had negative 2/3 x raised to the third plus 9x squared. So this is going to be equal to negative 2/3 9 raised to the 3 plus 9 multiplied by 9 squared, and then minus that 0. We're going to get our trusty calculators out, and we end up with whatever, 1/3 of 9 cubed times 2, and then subtract that from 9 cubed, and it looks like everyone has a confirmation of 243. Does anyone have any questions on that one? Okay, if there's no other questions, then let's take a look on the next one. So let me go back and give you a chance to write all that down before we go to the next one. Then we're going to talk about the next one with cosine and cosine squared. Okay, so when we take a look at cosine and cosine squared, just need to erase this so I have room, is once again, I'm going to try to determine who is above the other, and they're actually giving us our integration. So we're going from negative pi to pi. So I know what the cosine wave looks like. Cosine wave, so if I end at 2 pi, here's pi. So here is pi over 2. And my cosine wave would start at 1. It would go through pi halves, and then it would go down. It'd have a minimum at negative 1. And the same thing is going to be true here. So it's going to look something like that. So negative pi to pi is this part right here. And when I have cosine squared, that means that all of my answers are going to be positive. So it's going to have a slightly different graph. What I also know, without going to Desmos, and I will in a minute, is I'm going to set those equal to each other. So I have cosine squared x is equal to cosine x. So I'm going to bring the cosine to the other side. So cosine squared x minus cosine x is equal to 0. Just like before, above, where I factored out a negative x, I'm going to factor out a cosine x. So cosine x minus 1 is equal to 0. So when cosine, setting each one of these equal to 0 and solving, so I get cosine x is equal to 0. That happens when we're at pi halves and negative pi halves. And then setting this equal to 0, I get cosine x is equal to 1. This happens when x is equal to, in this interval, when x is equal to 0. So there are 3 places in which this graph will either touch or cross. So the 3 places is at negative pi halves, so right here, at negative pi halves, so right here, and at 0, so right there. So there are 3 different places in which these 2 graphs will either cross or they will be equal to each other. So when I do the integration of this, I got to figure out who's above and below each other in those regions. And I'm guessing that my cosine squared, and I'm going to confirm here in Desmos, because I don't know off the top of my head what cosine squared looks like, is I'm assuming that because it's squared, this is going to look something like this. But I'm going to go confirm that. That's what I think it looks like. So I'm going to go confirm that right now by going into Desmos. So let's go into Desmos. So let me erase this. So my first integration, and remember, because we have symmetry, I'm going to multiply this by 2, is I'm going to integrate from 0 to pi halves. In this region, my cosine is above my cosine squared. So I have cosine x and then minus cosine squared x dx. So that takes care of that first region. Now in my second region, so then minus, in my second region these switch, but I still have 2 of them, plus, and I still have 2 of them, and it's going to go from pi halves to pi. Now cosine squared is above the first one, so minus cosine x. And then dx. So even though I'm going from negative infinity to infinity, those are not my limits of integration. Those are just telling me which region I'm actually going to do the derivatives in. So when I'm asked to do the derivatives of these, I'm going to do it this way. I'm going to do 2 from 0 to pi halves of cosine x. And then I have the cosine squared x. So how do you think I want to complete this one where I have a cosine and a cosine squared? And I can tell you, U substitution will be your friend. So I'll just stop a minute. Can somebody tell me why I want to use this one and why U substitution didn't work out well on this? So with this Calculus 2, we bring together everything we forgot. We're bringing together algebra, bringing together our pre-calc 2, our trig. So this is bringing together everything that we forgot in one place. So all your derivatives you forgot, as well as integrations, as well as trig, as well as algebra. Why did my regular U substitution, can anyone tell me why my regular U substitution did not work? If you could unmute yourself and tell me why saying let U equal right here did not work. Let U equal. Why did that not work? If anyone's willing to unmute themselves. So when we thought it was just a simple let U equal, and we said, okay, well let U equal cosine x as an example, then du should be negative sine x dx. And I don't see that anywhere. Because I don't see that anywhere, then it is probably not going to be a direct U substitution. So what I then have to do is I have to get all of my trig identities out. And the trig identities that I see wherever I see cosine squared, and I'm going to send you the formula sheet that I give to my pre-calc 2 students. If you don't already have it, I'll send it to you again. Is I see, I'm going to look on my trig sheet. I'm going to look for where I see the squared anywhere. So I'm going to look all the way through it. I'm going to say, oh, well, I see squared in 2 places. I see it here, which is the basic identity. And then we see it also here. Because I see it, the second one, it allows me to eliminate the squared part, which is where my hiccup was. So I'm going to use that second identity to replace the cosine squared part. So I'm going to rewrite this as 2 going from 0 to pi over 2. Now I'm just going to do this first piece because you're going to do something similar for the second piece. And so I'm going to replace not the cosine, but the squared with 1/2 plus 1/2 the cosine 2x dx. And then it's not too bad of an integration, because then I just have to worry about the fact that I needed to have, when I did the derivative of negative sign, I'd better have had 2 there. So it's just a matter of doing the angle here as an adjustment. So I'm just going to rewrite this as 2 from 0 to pi over 2 of cosine x minus 1/2 minus 1/2 the cosine of 2x dx. And now I can integrate this. When I integrate it, the derivative of sine is cosine. So I know that this is going to be 2 multiplied by the sine, take off the integration symbol. So 2 multiplied by the sine of x, the derivative of sine is cosine. And then this here, this 1/2 should have been x to the 0. So it's then minus x over 2. And then minus. Now, if I had du of the sine of u, this would be cosine of u multiplied by u prime. So in this case, I know it's going to be 1/2 because that's still the multiplier. I know this is going to be the sine of 2x. But if I were to do the derivative of the sine of 2x, I should have had 2 as a multiplier, because that would have been what my u prime would have been. And so I need to adjust for that by doing another multiplication of 1/2 from 0 to pi over 2. And so what I have when I'm doing this integration, this is going to be equal to 2 the sine of x minus x over 2 minus 1/4 the sine of 2x from 0 to pi over 2. So now I'm going to go ahead and put the 0 and the pi over 2 in the right places. So this is going to be equal to 2. I'm going to do the sine of pi over 2 minus pi over 2 divided by 2 minus 1/4 the sine of 2 times pi over 2. And then I'm going to do minus the sine of 0 minus 0 divided by 2 minus 1/4 the sine of 0. Now, we love 0 because the sine of 0 is 0. So this whole thing goes to 0. So that's nice. And then what I'll have then is just 2. The sine of pi halves is 1 minus pi over 2 multiplied by 1/2. And then minus. This right here cleans up to just pi. And the sine of pi is 0. So minus 0, minus 0. So I've got 2, 1 minus pi fourths. And I can just leave this as 2 minus pi halves. And that is just the first region. I still would have to do the second region. Now, like I said, all I did was I pulled the first region, which was just going way back over here. Welcome to calculus, where one question takes up the entire page. All I did was this first one right here. I'd still have to do the second one. So I still have to do this second one. But I'm just going to go back over here so you can see all of it in its glory. I'm going to ask, what kind of questions do you have for me? So let's take a look at this last one, and we're asked to integrate this. So again, if you can remember what these look like without going to Desmos, it will save you time. So this is what e to the x looks like. E to the x looks like that. e to the negative x looks like that. And we're being asked to integrate between -1 to 1. Now, I have symmetry again, so I can just go to one of the two sides and decide which one I want to choose. I want to choose this side and then just multiply it by 2. Even though my e to the x is on the top on the right-hand side and my e raised to the negative x is on the top on the left-hand side of the y-axis, we have symmetry. These are the same shape. So because they're the same shape, I can just integrate from 0 to 1 and choose a side, or from -1 to 0 if I'm inclined. I'm going to go from 0 to 1, so I'm going to integrate this from 0 to 1, and my one that is on the top is e to the x. That is a function that's on above the other one, so minus e to the negative x dx. Then I need to multiply that by 2. Now, if I'm not going to use symmetry, that's totally cool. Then I would have integrated from -1 to 0. E to the negative x would have been the function that is above the e to the x function. And then I would have added to it from 0 to 1. Now e to the x is the top function and e to the negative x is the bottom function. So I can do this or I can do this. They are equivalent. It just depends on how you look at it. I see this as, I like putting in 0 whenever I can help it, and I like doing half the work. So I'm going to choose this one. But had you chose this one, that's fine. You should still get the same answer. So what we're going to be doing tomorrow when we pick this up is we are going to be looking at areas. We've already talked a little bit about areas that cross, because that was my sine or my cosine one, so we're not going to spend too much time on that. But we are going to integrate with respect to the y-axis. And notice when we do the integration with respect to the y-axis, it is going to be the value that is furthest to the right will be the one that's on the top. So this is what we consider, quote, the top function. And this is what we would consider, quote, the bottom function. So when we do this integration, and again, we can use symmetry. Because this is symmetric, I'm just going to integrate this side and divide it by 2. So I'm going to multiply 2. I'm going to integrate from 0 to 2, because now I am looking for the y values. And my top function is 9, or in other words, the one to the right, and the other one is y squared dy. So that's what we're going to be doing tomorrow. You all have a great day, and if I have set up a time to meet with you, I'll be meeting with you here shortly. Otherwise, I do have office hour today at 12:30 to 2 o'clock or by appointment. So that's what we're doing tomorrow. And then we'll finish off 2.1 with integration between curves.
Have a great afternoon.